Research funded by the Engineering and Physical Sciences Research Council, bringing together the private sector and academia in a range of groundbreaking projects, is leading the way in our search for alternative fuels.
Eventually we do need to make the jump, because otherwise we'll be stuck in today's system and today's fuels.
This is a transition that needs to happen in a relatively short time.
In order to make the difference in the future, it's essential that we act today.
Leading the call to action for net zero shipping is EPSRC, the UK's Engineering and Physical Sciences Research Council. Part of UK research and innovation, their funding not only backs solutions, but also highlights the problems. The task ahead does seem rather daunting. With around 61,000 vessels in the global trade fleet, only around 400 are actually using alternative fuels. And as welcome as that progress is, it is only a drop in the ocean. Some ships, like the Aurora, unloading at T-Sport, run on LNG, liquid natural gas. But it is still a carbon-based fuel. Science needs to find an alternative energy source that packs as much of a punch as oil and at a price the industry can afford by the net zero target deadline of 2050.
The movement of freight operates on very low margins. Heavy fuel oil and marine diesel oil are a very hard act to follow.
Professor Tony Roskilly is an unusual academic scientist, spending the first 10 years of his working life on cargo and passenger ships as an engineer.
So if you take the largest container ships, they use the equivalent of around 28,000 litres of heavy fuel oil a day. So that's an enormous amount of storage requirement. Most of the alternatives that we have available going forward to decarbonise are not anywhere close to the volumetric energy density that you have with heavy fuel oil. If we're talking about hydrogen, for example, you either have to compress it to very, very high pressures, or you have to liquefy it. And to liquefy it, you have to take it down to minus 253 degrees C.
Another fuel option is ammonia. It's easier to store as a liquid, but it is hazardous to handle. However, both are currently produced using natural gas. Now, scientists, innovators and industry are all being brought together by EPSRC to pool knowledge, expertise and ideas.
We are in a relatively early stages of the journey here. Again, we need to understand how much and how safely and environmentally we can produce hydrogen and ammonia, and then how this hydrogen and ammonia will be used within our existing engines of the fleet that we have nowadays.
Work is underway on how to retrofit today's fleet and how to design new ships from scratch. In his lab at Durham University, Professor Roskilly's team is producing environmentally cleaner hydrogen, which drives a new design of combustion engine that's 30% more efficient and carbon-free.
In here we actually have built an electrolyzer. So what we're doing is creating and splitting water into hydrogen and oxygen. In that whole process, you end up with heat. So what we're utilizing that heat for is to actually compress the gas. This is a hydrogen-fueled free piston engine. Basically, it's combustion in either end of the, in either cylinder here, and the system moves back and forth and generates electrical power. The next stage is for us to get this on the water in smaller vessels, and that's what we'll be doing in the next 12 months or so. Once we've done that, then we will be looking at scaling this up.
Research in this area wouldn't happen to the extent that is required without public investment, due to the level of risk really to individual organisations to take forward on their own. It's essential that we take the risk to discover new solutions and also to develop and deploy the solutions that we already have discovered.
In the UK, 95% of goods at some point travel by sea. And with shipping responsible for 2.5% of global greenhouse gas emissions, cleaning up the industry really could make a difference.
In some senses, the UK has good positions in all of the different technologies. The challenge is really around joining the dots and starting to have some really large-scale programs. In terms of sort of real commercial projects, I wouldn't be surprised to see something within 5 years' time, and we are already seeing a few pilot projects.
Radical change will require global cooperation or regulation. Infrastructure at every port will have to be adapted. and sooner than you might think.
The vessels will have routes that are tens of thousands of miles across the world.
Nobody's going to take this up in a big way if they can't refuel their ships. So this fuel has to be available at all the major ports.
There's a real recognition now that change is required and that action needs to be taken.